Picture yourself standing by the vast ocean, its rhythmic waves gently breaking against the shore. The sound is peaceful, almost hypnotic. But then, imagine being underwater, surrounded by silence, when you suddenly come face to face with a massive, unblinking eye staring back at you. That eerie feeling of the unknown is what scientists are experiencing with a recent discovery deep beneath the Pacific Ocean, an alarming leak on the ocean floor near Mount St. Helens. The Pacific, while a symbol of beauty and mystery, harbors secrets that challenge our understanding of the planet. From pollution to radiation, the ocean conceals issues that have far-reaching consequences. But now, this particular discovery near Mount St. Helens has scientists racing against time to uncover its potential threats to the Earth and its future. Mount St. Helens is an active volcano located in Washington State, USA, and has long been under observation due to its violent history. Its infamous eruption in 1980 devastated the region, claiming lives, reshaping the landscape, and demonstrating the raw power of nature. This volcano is part of the Cascade Volcanic Arc, a region stretching from northern California to British Columbia, Canada. It is one of the most geologically active zones on Earth due to the subduction of the dense oceanic plate beneath the North American plate. This process, known as subduction, is the driving force behind the volcanic activity in this area. As the oceanic plate dives deeper into the Earth, the immense pressure and heat cause water trapped in the rocks to escape. This escaping water melts the surrounding rock, forming magma which rises through cracks in the Earth's crust, eventually creating volcanoes like Mount St. Helens. Because of this volatile process, the region is continuously monitored by scientists using advanced tools. For decades, Mount St. Helens has shown signs of unrest. In 2004, activity hinted at its potential reawakening, and further movements were detected in 2014. However, it was in 2015, during a routine underwater mapping project, that something entirely unexpected came to light. While conducting sonar scans, researchers noticed strange bubbles rising from the seafloor near the Cascadia subduction zone, roughly 80 kilometers off the coast of Oregon. When they sent a robotic submersible to investigate, they discovered a leak, an underwater seepage unlike anything they had seen before. The team from the University of Washington named the site Pythia's Oasis, inspired by the ancient Greek oracle known for her cryptic prophecies. At first glance, the leak appeared to be a hydrothermal vent, which is relatively common near tectonic boundaries. These vents usually release hot water as part of geothermal activity. However, further analysis revealed that this was no ordinary vent. The leaking fluid was far more complex and troubling. It contained a mixture of volcanic gases such as carbon dioxide and methane, along with unusual chemical compounds like boron and lithium. Its composition suggested a direct link to magma beneath Mount St. Helens, indicating a connection between the leak and the geological activity of the Cascadia subduction zone. Even more concerning was the speed at which the fluid was escaping, 10 to 30 centimeters per second, a rate far higher than what is typically observed in similar areas. This rapid flow is likely the result of extreme pressure along the tectonic plate boundary. The fluid itself plays a critical role in the functioning of tectonic plates. Acting as a lubricant, it helps reduce friction between the plates, allowing them to move smoothly. However, as the leak drains this lubricant, it increases the likelihood of stress building up between the plates. When the stress becomes too great, it can release suddenly in the form of a massive earthquake. Scientists fear that this leak could trigger a magnitude 9.0 earthquake, what experts call the Big One. Such an earthquake would devastate cities like Seattle, Portland, and Vancouver, affecting millions of people. It could also generate a tsunami, similar to the one caused by the 2011 Tohoku earthquake in Japan, which led to the Fukushima nuclear disaster. The devastation from a similar event in North America would be unprecedented. While earthquakes are a major concern, the leak also raises alarms about volcanic activity. Mount St. Helens, along with other volcanoes in the Cascades, could erupt unpredictably due to the movement of magma linked to this leak. Volcanologists warn that a chain reaction is possible, where one eruption triggers another across the volcanic arc. This would endanger not only major cities in the Pacific Northwest but also the region's ecosystems and infrastructure. The potential for widespread destruction is significant, given the population growth and urban development in this area since Mount St. Helens' last major eruption in 1980. The environmental implications of the leak are equally troubling. The fluid contains greenhouse gases like methane and carbon dioxide. Although the current release rate is relatively small, a significant increase could accelerate climate change. Methane is particularly dangerous, being 80 times more effective than carbon dioxide at trapping heat in the atmosphere. Compounding this issue are the massive deposits of methane hydrate, frozen methane trapped in ice, found in the ocean near the Cascadia subduction zone. These deposits are stable under specific temperature and pressure conditions, but disturbances caused by the leak could release vast amounts of methane into the atmosphere. Such a release would have devastating effects on global temperatures and the Earth's climate. The leak has left scientists with many unanswered questions. Is this an isolated incident, or is it part of a larger system of leaks? Could there be other hidden leaks releasing dangerous gases into the ocean and atmosphere? To complicate matters further, the unique composition of the fluid, including its high temperature, 300 to 350 degrees Fahrenheit, suggests that it originates from deep within the Earth's crust. Some researchers believe this points to unknown processes occurring at the boundary between tectonic plates. Understanding these processes is crucial for assessing the potential risks. Meanwhile, emergency response teams are preparing for worst-case scenarios. Evacuation plans are being updated, and disaster management agencies are on high alert. The United States Geological Survey, USGS, has assured the public that there is no immediate danger, but they emphasize the importance of continued monitoring. Researchers are working tirelessly to study the leak, using advanced technology to analyze its composition and flow rate. Their goal is to predict the potential consequences and develop strategies to mitigate the risks. This discovery serves as a stark reminder of the unpredictable power of nature. Beneath the beauty of the Pacific Ocean lies a world of geological activity that can have far-reaching consequences for the planet. While scientists work to uncover the secrets of the leak near Mount St. Helens, the rest of us can only hope that their efforts will help us better understand and prepare for the challenges ahead. The atmosphere might experience temporary changes when Earth is shielded from the sun's heat, but this could disrupt weather patterns and negatively impact agriculture. Studies have also shown a noticeable rise in nearby ocean temperatures. This change, combined with chemical alterations in the area, is expected to create a marine environment unlike the one we know. Many species are leaving the region in search of more suitable habitats, while some species, which thrive in warmer conditions, are migrating to the affected area. However, it's not a smooth transition for these organisms. Natural events like this often come with abrupt chemical and biological shifts, which can harm species that depend on stable environmental conditions. If the leak significantly disrupts these factors, we might see mass die-offs of certain species and even entire ecosystems. The chemical composition of the leak suggests a mix of contributing factors. While much of the leak may stem from natural occurrences or long-standing events, other incidents might have accelerated its effects. One major event to consider is the Fukushima nuclear disaster, which occurred in 2011 after the Tohoku earthquake and tsunami in Japan. This earthquake, one of the most powerful ever recorded, triggered a tsunami that caused extensive damage, including the failure of power plants. At the Fukushima Daiichi nuclear power plant, the core of 3 reactors overheated, releasing radioactive contaminants into the environment and the Pacific Ocean. Efforts to control the situation included pumping coolant water into the reactors daily, but this also led to the discharge of radioactive water into the ocean. Despite measures like constructing an ice wall to contain the water, radiation still made its way into the Pacific over the years. Contaminated water and soil remain at the site, posing ongoing risks, especially with natural events and weather potentially spreading the pollutants further. Other human activities may also have contributed. For instance, a grounded Russian oil tanker carrying 200,000 gallons of oil struck a reef and began leaking, polluting the water. This oil spill caused concern, especially with the possibility of the substances mixing and creating unknown effects. Natural disasters like the eruption of Mount St. Helens in 1980 might have played a role as well. This volcanic eruption, the most destructive in U.S. history, devastated hundreds of square miles, caused billions in damages, and resulted in the loss of human and animal lives. To prevent such disasters in the future, we must seek solutions and improve our preparedness. Scientists are using advanced technologies to collect data, map affected areas, and monitor changes around the leak. Initial findings suggest that the leak is intensifying and expanding, indicating that magma reservoirs beneath the area may be becoming unstable. It is likely that more such leaks will be discovered, particularly in tectonically active regions, as climate change accelerates tectonic movements. These events often influence one another, highlighting the need for global collaboration to study and prepare for their impacts. Research institutions and geological survey organizations worldwide must work together, sharing resources, technologies, and findings to ensure no information is overlooked. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, can be deployed to monitor changes and collect samples, improving our understanding of these phenomena. One proposed solution is the use of containment technologies to collect gases released from the leak, reducing their environmental impact while providing valuable data. However, implementing such measures poses logistical challenges, including how and where to store the collected gases. These events also raise larger questions about humanity's role in influencing or mitigating such natural occurrences. Can we harness our technology to steer these events in a safer direction? Or are we simply observers with limited control over geological processes that have unfolded for millions of years? Perhaps our most advanced technologies are insufficient, and we should instead focus on innovations that help us adapt to living in a rapidly changing environment, or even on other planets. As scientists continue exploring the ocean for similar leaks, we are reminded of how vast and mysterious our world remains. For now, the questions are multiplying faster than we can find answers. We can only hope that we uncover solutions in time to address the challenges ahead.